It is with a heavy heart that I announce the death of DevOps. I'm sure you must have heard or have seen the circulating YouTube videos talking about the fact that DevOps is dead and you shouldn't invest in DevOps and you have to go to cloud engineering or you have to go to platform engineering or anything else, but not DevOps because DevOps is dead. And as usual, I don't speak or I don't make up things. We are going to look at evidences and validation for my claims against the other videos that I just mentioned, whatever they mention without any evidence or any proofs, either due to ignorance or maybe they are just repeating like parrots what they have heard in other videos, or maybe they have some personal aims behind that. Whatever the reason is, this video is going to nail it down with evidence, with proofs. So stay tuned and we're going to discuss all of this. Okay, first of all, DevOps is not dead. So that's the good news. But in order to understand this short sentence or this statement, we must understand what DevOps is. So in case if you are not aware what DevOps is, so please listen up and you are going to find out a brief introduction and then I will take you into why people think that it has died. So let's go through a quick overview on what DevOps is. In the software development lifecycle or the software development process, what happens is we have one or more developers working on code. They have already received the requirements. There is a need, and these requirements have evolved into a project, and the project has been assigned a number of developers or maybe a number of teams, and each one has multiple developers, and they were going to start working on code. So when they collaborate on that code, whether within a team or across the different teams, then whenever there is a change, something has been done in the code, they have to upload it to what we call a repository, or they have to commit it to a repository. And GitHub is one example, but then we have Bitbucket and other examples as well. A Git-based repository basically that is on the internet. So they upload their code, maybe hourly, maybe daily, maybe twice a day. It depends on how fast and how frequent they make changes. And then we have team members that what they will do, software engineers, software testing engineers, what they will do is are going to build the different components of the code into an application or a draft application. And then they will run some predefined tests and find out if everything is cool. If they have any issues, then they provide feedback to the development team so the development team can look into it, fix it, and the loop goes on until the software is good and then it becomes a releasable or an available new version of the code. So that's the process. And of course, depending on which school, some schools, they would say that this person must be a professional developer, full stack, back end, so a competent developer so they can fix problems they find in the code and they don't go back to the developers unless it is a big problem. So that's what happens. And the software development workflow goes through requirements and then planning, and then the developers work on code, and then they build the drafts of the code when they commit the new code, test it, and then the loop back, the feedback goes on until it is released and then deployed and then operated or operations and so on. New feature, so the cycle repeats again and again. Okay, so we write the code and then we build the code into application and then we test and do the errors and feedback and then it becomes released and deployed and then we can run it. So it is critical to ensure that we have tools in place to automate the different tasks in any software development process. In any one of these stages, we would like it to be automated, not manually processed. And this is where the DevOps need came from. So the DevOps brings what we call a continuous integration or CI and a continuous deployment or delivery, which is the CD. So either a release only or a release and automatic deployment. So the developers will push their code into a repository in GitHub, for example, and that's called committing the code or pushing the code. And that would be then building and testing until we have a released deployable code. So that's the CI. And then for the CD part, we take the committed code as we mentioned in the CI. So now we have a staging area where we have the release software. And then from there, it can go through continuous delivery where we have an approval. And then we can work on deploying that after the approval. So we have manual intervention to review and approve the change, or it goes through automatic deployment after release immediately. And of course, this carries a lot of risks, and we have to have a very thorough testing. Otherwise, you can get surprises. So this is more common. However, this is also used with rigorous testing to ensure that we don't have any problems in the software. So that's what DevOps promoted or started promoting, the CI and the CD. So DevOps engineers at start, all they wanted to know was to know how to automate the building and testing and to take the code from the repository until a release is available and help with the deployment. That's it. But then it evolved to include a lot more tools. It's not only CI/CD. The common CI/CD tools are what you see on the screen, and there are plenty others. But then it evolved to include a lot of things. So the DevOps engineer is now expected to know a lot more tools. Now, if we're talking about the deployment, so you need to know the cloud. You need to know AWS. But maybe you're helping another team that will go on Google. And then Azure. And you need to know Kubernetes. So Kubernetes on AWS is called EKS, the managed service. And on Azure, it's AKS. And on Google, it's GKS. You need to know Kubernetes, and then you need to know the different ways of dealing with the managed flavor of services. You need to understand Docker. You need to know infrastructure as code. You need to know, and the pile just kept increasing. And these are all skills that the DevOps engineers need to know. And here's a simplified version of the ecosystem of tools that talks about the fact that the DevOps engineer needs to know a scripting, one or more languages. Bash and Python are very famous here. You need to know CI/CD tools. Jenkins used to be the front runner, but now GitLab and Argo CD and Azure DevOps and GitHub Actions are also gaining popularity. Build tools, depending on what language the code is written in, then you probably need Maven, Gradle, or you need to use Docker or other tools to package, to build the code into an application. And then you need to have repositories. So GitHub is one example, Bitbucket is another example, and there are others. And then the deployment tools, you need to have at least, the newest is Ansible, and Ansible is going to help you with the configuration management. So after deployment, how can you configure the applications? That would help you to do it centrally. And from there, most of the deployments are going to be containerized or microservices fashion, cloud native. So that's why you need to know Docker and Kubernetes, and sometimes Podman to replace Docker, sometimes OpenShift to replace Kubernetes. But these are the ones that people will be looking at. Then for reporting and monitoring, you need to know Nagios, you need to know Prometheus, you need to know Grafana. There is visualization and observability tools. You need to know also some logging tools, Tableau or Grafana for visualization, and so on. There are plenty of tools that you need to know some of them, and then we talk about scanning and DevSecOps, where SonarQube and other stuff also come into play. There is a lot of skills that the DevOps engineers need to know, and that is a challenge because now you need someone who will spend probably, 9 to 14, 15 months to learn all these tools, do projects, get relevant certifications, and then they can apply. And that's why a lot of people, they would say, this is not for beginners. Okay, beginners mean someone who can pick up some books, do some labs in 2-3 months, and then that is a fresher. DevOps engineers, they have to have all these tool or skills in their toolbox or under their belt before they can become DevOps engineers. So that's a challenge, the number of skills that they need to work on. The second challenge with DevOps engineering, the way it is it doesn't care once it is deployed without problems. I don't care about whether it is performing as expected. Is the application providing the right response time levels or not? And is it glitchy? What is going on? Under load, what happens? This is not their problem. That's not what they care about. So now we have the number of skills they need to cover. And the second one is the fact that they don't take observability or monitoring after the fact, after deployment, into account. So they just throw it over the wall to the operations team and they take care of it. And that has brought SRE into play, the site reliability engineering. Because in site reliability engineering, the concept is different. The observability, the performance, the logging, the fact that we can bring the SRE engineer when we have an outage at 3 o'clock in the morning or when we are doing a deployment, they have to be on the call and maybe they will be deploying what's happening. And they need to make sure that they have the right tools in place to monitor the performance, the reliability, the resilience, and how the application or the software is after deployment. And that's why we started to see that some companies are asking for SREs and some companies are asking for DevOps engineers. What actually happens here is a lot of companies, what they did is they said, okay, you are the DevOps engineer, but we don't have anyone to do monitoring and observability. So why don't we'll send you on a course, or maybe you need to study Prometheus, Grafana, Datadog, Dynatrace, any one of these tools that they are going to use. And we need to make sure that you are going to be on call when we have an outage. So we are going to call you at 3 o'clock in the morning. So they added more stuff on the DevOps engineer, which equals an SRE. Okay, so why do we need the site reliability engineers, or who came up with this idea? That was Google, and they have the SRE Con. They have a conference for site reliability engineering, and they discuss that the site reliability engineer, they have to strive for simplicity, don't complicate things. There will be a risk embraced working on new technologies and deploying and all that stuff, so that is also part of the SRE. We are going to use service level objective. So we aim at keeping the availability of the application 99.99% of the time. There is a service level objective. So we will endeavor to keep the application running this percentage of time. And usually it is 99.99 at least. We're going to eliminate toil. Anything that is done repetitively, we need to get rid of redoing it. It has to be automated. We are going to monitor distributed systems. We are going to make sure automation is done all over the place, and we will do release engineering as well. And you can go here if you want to know more about site reliability engineering itself. So we understand now that we need the SREs and we need the DevOps. One important thing to look at is SREs and DevOps, they should be complementary. They should not be either this or that. But some companies, they have added more skills or requirements into the DevOps, and that becomes like a pseudo SRE, but they call it DevOps engineering. Some other companies, they said, no, it's SRE, but then they give you all the tasks for the DevOps as well. So the lack of standardization led into this, but there were legitimate reasons for them to look at additional skills. But still, at this point, whether SRE or DevOps, now, if the corporate is large and we have hundreds of developers, we are going to have multiple teams of DevOps engineers and or SREs. So there could be both positions available. So DevOps engineers and then SREs for monitoring and all that, the uptime of the application, or they could be combined. But in either case, if I have hundreds and hundreds of developers, then the response time, how fast the DevOps and SRE can finish the requests, became an issue. So SRE's focus will be in incident response, and they will use precise reliability metrics, server level indicators, service level objectives, error budgets, and so on. And they are responsible to find out what went wrong and why when we have outages. And of course, the SRE team are going to be involved in any one of these tasks. So SRE focus is reliability, whereas the DevOps focus is delivery. So now developers in a large environment are still complaining that the DevOps teams are not up to speed. They can't keep up with our requests, and then there is a delay for the releases and the new features and so on. And of course, the business people will be asking the program managers or the CIOs, who will ask the program managers, the project managers, until they find out that the pinpoint is DevOps team are not responding fast enough. So now the term that evolved is called platform engineering. They sat down and said, okay, what is the problem now? What's the problem with scaling DevOps? Why is DevOps slow? And the reason is, we mentioned, they were overwhelmed with tasks, and also the overwhelmed with the technology stuff that they need to cover. I have different developers, they come from different backgrounds. Some prefer, or some teams will prefer Java and deployment on Google. Others will prefer, let's say, C#, or maybe Ruby on Rails, or they are doing mobile applications or whatever they are making, and they prefer to work on AWS or in Azure or maybe on premises. So now we have lots of skills that we need to cover, and we need to respond very quickly, and the requests are like raindrops coming all the way, and we cannot stop them. And these are the overwhelming tasks with DevOps: running infrastructure as a service, running Kubernetes cluster, CI/CD, infrastructure as code, security and monitoring, and so on. The other problem we have is, when we have multiple teams, it's very hard to standardize. How can we ensure that governance and compliance are implemented? We have some team that are perfect working on Google, and the developer team is very happy with them. However, they don't know anything about security and best practices as far as security is concerned. But the corporate has standards for security. We cannot be exposed. We cannot have problems with the code. We cannot be hacked, or we should not be hacked. So how can we ensure that the corporate policies and standards are implemented? It's very hard when we have diverse teams, and when we try to scale by building different teams with different skill sets without any competence or ability to audit their compliance to security and policies. So these are all problems. And that's why platform engineering emerged. So what's platform engineering? It's the discipline of designing and building tool chains and workflows that enable self-service. So the key point here is, why do we have to have multiple DevOps engineering teams where we cannot standardize and the cost is higher? And they are overwhelmed, and we're not getting the result that we are expecting, which is no errors or high quality code and very quick releases of features and software. So they said, okay, fine. Developers are complaining, but at the same time, they don't want to take over the DevOps engineering tasks, and the DevOps engineering teams are not quick enough for them, and that's why the whole thing is slowing down. So they said, okay, fine. Can we build platforms, self-service platforms, where the developer can go in there without having to know everything about Git and GitHub and Docker and Kubernetes and AWS and all that stuff? Is there a way for them to have that platform where they can log in, and then they can click, and then a repository on GitHub is created for them? Then they click again, a pipeline is hooked into that repository, and now it is ready. And then they click, 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 click. They put the testing tools, they put the deployment tools, and everything looks fine. And they develop and commit their code, and life is good. So if we can reach that magic, this is what platform engineering is. So the aim is to build a self-service platform that they can use it themselves without waiting for anyone, and it can help them build pipelines and test and use scripts and build stuff on the cloud and all that by simple clicks, without them having to take care of the responsibility or the skills of building that or maintaining that. And that becomes the platform engineering team, which will build and maintain that. So we're looking at something called the IDP, the Independent Development Platform, where the developers or development team, they can use, and it can accommodate all the services that they need, the different teams, and it will be configured according to security best practices and corporate policies. And all they need is they are going to use it without knowing what's the underlying services used. And we are doing that. If you think about Azure DevOps, when you go to the Azure cloud and you start to use their own tools, or AWS, the code build and the code pipeline and the code deploy and so on, all of these are tools that give you a graphical user interface, and we don't know what is the underlying tools. They could be using Jenkins, they could be using GitLab, they could be using their own tools for CI/CD. We don't care, as long as it can help us integrate our testing and release our software and get deployed. That's all I care about. So we have been doing platform engineering, but we have been using platform engineering, but AWS engineers have built it for us. Same thing on Azure, and same thing when you are dealing with OpenShift, for example, or when you are dealing with Google Cloud. So when doing this, that means I will have here teams who are working day and night to maintain that platform updated, to maintain it secure, to maintain it configured properly and with the right tools. And they are going to be the ones maintaining the Terraform scripts that are going to do things on AWS or on Azure or on Google when the developers click on something, or maybe they will just do an API call into GitHub to create a repo. Okay, so the breakdown into platform engineering is the core is a reusable internal development platform that is going to have all the tools and systems that make it easier for developers and operation teams to build and test and deploy and run applications efficiently. But then the question that arises is, does it mean that when you have platform engineers, so SRE and DevOps are dead? And unfortunately, this is the deception that everyone else was talking about, that DevOps has died. No, it hasn't died. It has evolved. And due to lack of standardization or different issues companies of different sizes were facing, they either threw skills for CI/CD into cloud engineering or into SRE, or they have combined DevOps and SRE and they called it either DevOps only or SRE only. Or maybe they are a small company, they brought in the cloud engineer and they have a couple of developers. They said, okay, why don't you scale up and learn CI/CD tool of such and such, because the developers would like to use it. You're going to help them with the pipelines and you are already doing the cloud and monitoring and all that stuff. So why don't you do this one as well? So what is the market asking for? That would be the judge, right? Are there still companies asking for DevOps engineers? Are there still companies asking for SREs? And are there still companies, or is there companies asking for platform engineering? And the answer is yes to all three questions. Let's go ahead and look at dice.com in the US, the largest IT market in the world, and find out what are the trends. And this is what is going to filter down and go into the other geographies, right? So I'm on dice.com right now, and I have DevOps engineer as the search request, and I'm going to hit enter. And as you can see, there is more than 1,000 jobs, and there are 26 that were posted today. That means there are jobs, and there is 1,000 plus that are available today. So DevOps engineer, senior DevOps engineer, DevOps engineer, DevOps engineer, DevOps engineer, and so on. So it still exists. And as you can see, yesterday, today, so these are all fresh ones today. And also you can see the rates that are going from $60 per hour. So that is 120,000 per year. And this is 100 to 120,000. This is full time. This one is a contract. And you can give it a try and find out what you'll get as a result for the rates and for the jobs. And of course, you can click on any one of them and you'll find out the responsibilities will include CI/CD and will include other stuff. Remember from my previous video about do you have to be a developer to be a DevOps engineer? You will find some of these jobs, they are also expecting you to be a developer or an ex-developer. So some of these would be like that and some others will not be like that. They will expect you to know fundamentals. And I am leaning towards that as the right approach, because if someone made a code that I'm testing as a DevOps engineer, I might be able to fix two minor problems, but I don't want to spend my time with the fact that I'm already overwhelmed with DevOps work in order to fix the developers' work. I should give them the feedback, they should fix it. But some companies, they would say, no, and we need both. Maybe they will use you as a developer / DevOps engineer. So that's the first one. So DevOps engineer jobs still exist in the largest IT market in the world, which is the US, and that confirms my claims. Now let's look at site reliability engineers. So I have here site reliability engineer only, and let me find out. So we have 1,045 jobs, out of which 18 are new. So there are still companies looking at that, and you'll find different rates, of course. So this one is 84 to 165 depending on experience, Microsoft Corporation. So Microsoft itself is asking for SREs. And then we have site reliability engineer, and this is going to be 65 to 75, so up to 150,000 per year, if you go for a long-term contract. And then we have, so all of them, they are going into that range, which is 130 to 150, or maybe a little bit more. Microsoft was more than that. So Microsoft was up to 165 and $200 per year. So Part of the claims that have been circulating on YouTube as well, the fact that the salaries have dropped by 6%. Yeah, that's a very natural evolution of any technology from inception through the hype to saturation until it becomes saturated plateau or it starts the demise. Now, what about the platform engineering? Is anyone asking for that? And you can see platform engineer. And we can see also there are companies asking, and you can see that the pay is within the same range. Senior platform engineer, $30 to $40. I mean, this is very low. And then we have, depends on experience, 60 to 70, so that's 120 to 140. Platform engineer. If you look at the numbers, you'll find that there is 1,100 and something, and then 30 new. So the bottom line here is we have 1,000 plus, 1,000 plus, 1,000 plus. All are between 1,000 and 1,100. So equivalent number of jobs that are being released every day, as we see here, or at least for today, and they are comparable, and the pay is very comparable as well. So that proves we are talking about perceptions or how different corporates have adopted or have identified what they need. Some people, they love the platform engineering idea because they have a huge development team and they would do it. But we have seen that Microsoft was asking for an SRE, not a platform engineer. So still, even the big corporates are still adopting one of the three approaches, and that means it did not die. DevOps did not die. So could they all exist in the same corporate? And here's a real world example where the platform engineer is going to build the self-service portal where developers will click a button and get a repository, a CI/CD pipeline, a deployment target in a staging or a production environment or development environment in one of the clouds, and built-in monitoring and logging and alerting and so on. The DevOps will set up the Argo CD or the CI/CD or the Helm charts and CI/CD pipelines. By the way, if this is going to be the platform that will have all the Terraform and Ansible and the different scripts and all that are going to be built within, then who within this team will understand CI/CD to start to set up the CI/CD tools that are going to be in the platform? There has to be a DevOps engineer within the team. So they will set up the Helm charts, they will set up the CI/CD pipelines and the Argo CD for GitOps, all they will do it into the platform. And SRE will monitor the deployments to ensure that latency, performance, and so on is working without any issues. So there is an integration between the three roles if a company adopts all of them. Or they could be all blended into one pot and they become either the platform engineer only or the SRE team only or the DevOps teams in the corporate. All right, so the bottom line is DevOps is not dead and it has evolved. That's the bottom line. Now let's take a step back, because also people who have been circulating these videos, they are missing a big point, or maybe they don't understand it. So let's compare what are the skills that are required for DevOps as opposed to cloud engineering, as opposed to SRE, as opposed to platform engineer, to find out, is it like a completely four different sets of skills with no overlap between them? Or is there a major overlap? And even if they stop hiring DevOps, I can, in 2-3 weeks, I can switch and become an SRE. Or in another 8 weeks, I can become a platform engineer. So it is you and the skills that you know, irrespective of what they call the role. You can write a new resume, a new CV, update it, and then you start applying. Because you have done the job, you know the skills, and it's only the name. Okay, fine, I'm going to have a new version of my resume and start applying. So if we look at what is required, this is what is required for the DevOps engineer. If you noticed here, Ansible is included, cloud environments are included with certificates, and Red Hat for Ansible covers Ansible as well, Linux, Kubernetes, Terraform, Python automation, Bash scripting, and we have Terraform included. So all of this has been shifted or shipped under the DevOps engineer skills requirement. And then we have either Jenkins or GitHub Actions or any one of the tools. What's the difference between a DevOps engineer and a cloud engineer? The cloud engineer will mostly stop here and will go deeper into the cloud by adding maybe professional certificates, SysOps admins, getting more into cloud formation and other vendor-specific or cloud provider-specific tools. So all of this is common between cloud engineers. I'm talking about knowledgeable cloud engineers, not someone who just takes the cloud practitioner and SysOps administrator or maybe the solutions architect associate and they call themselves cloud engineers. So this is the difference between the two. What about the difference between DevOps engineer and SRE engineer? You'll find that the tools that will help you for monitoring, for visualization, and for logging. This is the difference. And these tools, in order to learn them, maybe you need another 3, 4, 6 weeks. So that's the difference between the two. What about platform engineer? You'll find that there are other skills like backstage, and this is used to build the IDP, the platforms, the self-service platforms, cross-play for API availability, and then Argo CD for GitOps. And this again, if you look at them compared to this set of skills, this would take you maybe 8 to 12 months, 8 to 14 months, depending on which certificates you are going to take and where or which level you are starting from, a newbie or you have been in IT but upskilling. So each one of these is going to be, let's say 6 weeks, another 6 weeks, 7 weeks, 8 weeks, whatever it is. Because you know the concepts, you understand everything, you have done it, you have done projects, you have the certification, and you have confidence that you can do any one of these jobs. Now, you add another 6 weeks, have one resume for platform engineering, one resume for SRE, one resume for DevOps engineer, and one for cloud engineer, and apply. As long as you know it, you have mastered it, and you have done projects, and you have certificates under your belt, be confident and go for the interviews. So I would apply for all of them. So the bottom line again is it did not die. DevOps did not die. And don't listen to anyone telling you that. If someone tells you don't do DevOps engineering and do cloud engineering, I would say, heck, what's the difference? 3-4 weeks to learn Jenkins? Are you kidding me? I'm going to do both. I'm going to apply to both jobs as opposed to only cloud engineering. Or maybe I'm going to be a cloud engineer that knows CI/CD, so that I can apply into startups and small companies, and for them I'm going to be an excellent hire because I can cover for them 2 jobs instead of 1, and they can now save their limited budget into other stuff. So that's how you should be positive, and that's how you should challenge anyone telling you don't do this and do that. Go and research. Go on ChatGPT and ask, did DevOps engineering die? Why are people claiming that DevOps has died? And what's the evolution? What's the new concept? What are people looking for? What are companies looking for? And now I go into dice.com and find out the skills and compare that to my skills and find the delta and start working. That's how you should behave, and that's the positive attitude that you have to carry on with you as an IT professional in the modern IT. That's how it works. All right. So again, DevOps is alive, SRE is alive, cloud engineering is alive, platform engineering is alive. The common set of skills is your Swiss knife that will get you into any one of these. All right. So that's it for now. And please subscribe to the channel. I have less than 40% subscribed from the viewers and audience on the channel. That is not the right way. And please update or activate the notifications. And if you like the video or have benefited from the video, please give us a like and share it with others so we can have everyone benefit from this video. I'll see you in the next video. Thank you.